Hi, everybody. Welcome back to the Astro Imaging channel. This is Alex. I'm going to cut short the announcements a little bit today. I do want to have well, I would have liked to have had Curtis step in, but it looks like Curtis has stepped away from his computer for a minute or three. Let me take you over to some of the other things I wanted to show you. Share. As always at this time, oops, wrong one. There we go, calendar. Jasem and Robert and Hi and Eric are here today to tell us about Ekos, the software system that can take all your pictures for you and things like that. And they've got a tag team that are going to do a whole lot of work with this. Then Curtis is going to be here next week, and hopefully we'll have him. We've got a whole lot of other good shows coming up. I also want to remind you that we actually had a dearth of galaxies this week. I don't know what happened, but we only got about 2 new galaxies in all the week. So please get your gorgeous galaxies in so that we can continue with our effort to make a slideshow for us. And I think that's about all I'm going to be doing there. Let's see. Here, don't forget to put all your questions in over here. And if you've got any questions for the Ekos team, please add them in over here. They're here. They're ready to answer your questions for you. Okay. Is Curtis back? Is Curtis back? Where's Curtis's blank? Curtis is not back. Okay. So I'm going to stop presenting and turn it over to Jasem. Could you introduce your team and go ahead and tell us what you know? You're on.
All right. Hello, everyone. This is Jasem Mutlaq. Let me just start the presentation here in a minute. And regarding the team introduction, so this is going to be...
Okay, hang on a minute, Jasem. Looks like Curtis has arrived. Curtis.
Yeah, sorry about that.
That's okay. Can you tell us just briefly what's going to happen next week with the power to the people?
Yeah. So I spent most of the last year trying to get away from bringing a gasoline generator out to Star Party, which is not very friendly, or swapping out 2 big, heavy 100 amp hour lead acid batteries into my van back and forth. So I spent a lot of time working on improving my setup in the field. So I'm going to talk about 3 things. First, how do you figure out how much power, and it's not really power, how much energy do you need when you go out into the field? Second, what are some of the latest and greatest options in terms of power sources? And third, how the heck do you connect all that stuff? And so hopefully some of what I will talk about will be new to you. Some will be new, some in each area will be new to each different person. But hopefully it'll be helpful. Okay?
Thank you very much. And back to the regular program. Go ahead, Jasem.
All right. So hopefully everything is getting shared correctly now.
You're looking good.
All right. So hi again. This is Jasem Mutlaq. I'm the current maintainer of KStars, of which Ekos is just one part of KStars. And everyone actually will do introduction for themselves and part of the team. So I'll let everyone talk about what they do when their turn comes by. All right, so this is me. My name again is Jasem Mutlaq. I'm the INDI maintainer. So INDI is the driver side of Ekos. This is how you connect to equipment. It's equivalent to ASCOM, but we support Mac OS and Linux. I'm also currently the KStars maintainer, so I oversee the project, the team, the code review, some of the code review at least, and the overall plan for the project. I'm also founder of Icarus Technologies, which is a company specialized in astronomy. I'm from Kuwait, and I spent 20 years with KDE, which is an open source project meant to provide desktop environments and a host of application software that are cross-platform. KStars is one of them, but we have a lot of software like Krita and other software, open source software that we provide for the community. All right, so let's just talk about KStars. So the reason we're talking about KStars is, again, Ekos is part of KStars. And sometimes people confuse the two. So KStars is a desktop planetarium. It was started in 2001 by Jason Harris, who was an astronomer at the STSI, Space Science Telescope Institute. And it just grew further. We have a large team of international collaborators from all over the world. Around 2003, we started with the INDI integration, which is the driver integration to control your instruments. So you're talking about mounts, cameras, filter wheels, etc. And around 2012, there was missing in the ecosystem, under Linux at least, a program that would smartly utilize these drivers in order to perform your typical astrophotography workflow. So there was none back then, or there were like a loose collection of software applications that you have to use individually, and it was a nightmare for any novice users or even experienced user. So this is why Ekos was started 2012, and of course it grew since then. It's coming now to 10 years almost, and we expanded from a Linux only client to support Windows and Mac OS, and this started 2016, thanks again to the huge help and support we got from our international team of volunteers. We also started on doing, so Ekos can control your instruments, but would it be nice if you can just, schedule your sessions and then just wake up in the morning with your data ready? So this is where we started in scheduler automation in 2018, and this is all an iterative, ongoing process. So this is how KStars looked in 2001, and this is how it looks now. This is under Mac OS, and so we took a lot of strides to get to where we are today. So now let me talk generally about Ekos architecture. So Ekos is a program for astrophotography. It is intended to allow you to take your images. So it's a data acquisition program. It's not meant for any processing of the astrophoto. It just helps you to take your photos, and then you can process them later. So here we see the local mode, what I would call the local mode, and this is what most users would be typically familiar with. You have a PC or a Mac, and then you have your instruments. You have a mount, cameras, etc., and then you connect these instruments to your PC or laptop, either through USB, Ethernet, Wi-Fi, any communication medium that exists today. You can do that, and then you just open your program, whatever that is, and then you have a full control over your instruments. So this is the local mode, and this is what most people are familiar with. But Ekos actually, and so what's unique about Ekos and INDI, this combination, is that we have a built-in transparent network support. So this is one of the major feature of Ekos, in which you can use it in a server client architecture. So your client, which is your Ekos program, can talk to your server, which then connects to these instruments. So they don't have to be on the same location. They can be at a different location. All you need is some internet connection or LAN connection. So you need TCP/IP connection between the client and the server, and then you can connect your instruments. So this decouples the client side from the server side. And it doesn't stop there. So this connection here, this is called one-to-one connection, right? But Ekos and INDI has this architecture that is truly scalable to many connections. So you can have many servers. Here we see on the left side, you have your PC client or Mac client, you have a tablet, and maybe you have some specialized clients that are loggers. Maybe you have a watchdog client that's its only purpose is to oversee the security of your observatory or your equipment. And in case anything that happens, it just monitors and then takes corrective actions to secure your instruments. Here on the right-hand side, we see that we can have any servers, and it doesn't have to be big fancy servers. You can actually run everything on a Raspberry Pi, $35 Raspberry Pi, and this is what most people actually use. Almost nobody uses huge servers unless you're in a professional level observatory. And what's unique about this picture here is you can have the server meshed together, and it can be in a different geographical location. This is not typically the case. You typically have it in a close by location, in a similar location. But actually, the architecture at least supports this scalability between many clients connected at the same time to many servers that are connected to your equipment. So for example, you can have your weather station with different Raspberry Pi, and that is meshed together with your other servers. And this is all truly transparent to the client. The client only talks to one server, and everything else is presented to them. So this is where truly the INDI architecture scales with Ekos. All right, and now we go over to Eric, who will explain in detail some of the details of Ekos. So over to you, Eric.
Okay. Thank you, Jasem, for this very nice introduction. So, is that okay? Yep. So,
yeah,
my name is Eric Dejouhanet. Let's say in French, Eric Dejouhanet. I'm a software development operation now. I worked for 20 years in digital TV, and I've got a small company that acts in astronomy, INDI drivers, and things like that during the night. I'm living in the French Brittany, the cloudy French Brittany. It's not very nice for astronomy, but well, it works. So on the picture, this is my small observatory in the backyard of my garden. That's very simple, a very simple setup that I use to develop actually more than take pictures. I'm a KStars and INDI developer, and my contribution to Ekos during the last years was mainly on the scheduler, the focuser, and PhD2 interaction. And the biggest part was to create tests for Ekos in order to track issues, to track regressions, and to go forward with new features. We'll review the different modules of Ekos. Well, this is only an overview. If you want to go further in details, you can download it for yourself and have a look. This is oriented towards beginners and also allows you to control every part of your devices and hardware. So the main part of Ekos is the manager module. Ekos relies on INDI profiles in a big library of devices. And while Ekos runs on Linux, on Windows, and on macOS, INDI is mainly Linux. So devices can be local if the driver is installed on a Linux machine, but can also, as Jasem said, can also be remote. And the main page of that manager is designed to display the progress of an observation. The capture module is responsible for exposing, capturing your frames. You can configure it for duration, filters, count, delays, whether you want raw and fits frames, whether you want light frames, flat, darks, bias. You can configure the subframing, the gain, the offset. You can also use directly INDI properties to send to the device in one shot. You have the temperature, on this picture, there is a new feature that is not displayed, the temperature ramp-up that was recently added. You have also a filter table that I rendered on the bottom, which adjusts the focus position for each filter based on a particular feature. You can, for instance, focus with the luminance filter and then offset for the red, the green, the blue, and the narrowband filters. To detect there is a deviation either in focus or guiding and suspend before other modules take over and adjust the situation. Talking about focusing, the focus module responsibility is to adjust the position of the sensor. It also has some capture settings in terms of binning, gain, and also filters. There are settings for mechanics, how much we should go out or in with the focuser. There are various algorithms, iterative, polynomial, linear, detection procedures also, detecting by gradient threshold or SEP. The HFR computation, so the half flux radius computation is can be calculated over the full frame instead of a single star. As displayed on this page, you see two blue rings, which is an annulus star selection that helps with refractors like Takahashi's, which are difficult to focus sometimes and require focusing on an external ring instead of the center. Next, we go to the align. Oh, I forgot to tell that there was the Batinov process also. You can focus manually with that module. So next we go to the align module. The align module adjusts the orientation of your mount based on sky charts. Here also you have capture specs. There are 3 PlateSolver providers, PlateSolver client providers, local or remote. We use the StellarSolver mainly now, but you can also connect to the Nova API on astrometry.net or any instance of ASTAP. The module is able to simply sync what it sees so that you use it for manual operation. You point your telescope, your Dobson, for instance. If you have a camera connected to your telescope, you take a picture, you ask Ekos to solve, and then Ekos shows you where you are on the sky chart. It can also slew to target directly. This is for automated processing. You can generate your mount model so that you don't have to plate solve every time. And you also have the polar alignment tool and specifically the align anywhere polar alignment, which will be described by Hai later during the presentation. So connected to the align module is the mount module. The mount module covers the observation setup for imager or guider optical path. So this information is used at several places in Ekos, mainly in the align module, not mainly, but for instance, in the align module. There is a control pad on the top right. You see your, so the control pad allows you to have in a single place all information to to slew to a particular object that you can look into the database of objects of Ekos, or to use buttons to move your mouse manually, or to enter coordinates directly, either in equatorial or azimuthal coordinates to slew to a particular place of the sky. Here you have the meridian flip management, which is a big part of the module. There is an auto park also at a specific time, and movement limits. Clear all configuration set in the mount device in case you haven't done configuration for a few weeks and the hardware drifted, and the meridian flip doesn't happen when you want, for instance, or if you let the camera hit the tripod and now the encoders are offset. There are also cases where the parking position can be wrong and you can reset everything here. The guide module, I will talk about this later in the presentation. Its job is to lock a star onto the same pixel for the duration of the exposure. There are three clients for this: the internal guider, the PhD2 guider, and the Lean guider, which is a bit older. The guide module controls the PhD2 through the server API, and also reacts to PhD2 changes that you may do on the PhD2 interface. For the guider, internal guider, you have all in the integration parameter controls, and you can start calibration. There are there is a periodic error correction. I should say correlation that adapts to what the periodic error is. Well, how the client, the guide module sees the periodic error and can correct for this after some time. This is the GPG algorithm. There is differing, and the guide module will abort automatically guiding when the mount slews or flips. Everything is set up for automation in the background. And this is where I go to the scheduler module, which is the orchestrator of automated observations. You select, you choose in the database or directly via coordinates the object you want to capture. You choose a sequence file, which is how the capture module takes exposures. You set up a scheduled job. In that interface, you press play, and Ekos will slew to the target, focus on the target, align if it is needed, and start guiding with calibration also if needed, and then take all your pictures. And when it's done, it will switch to the other scheduled object. What we tried to do is to be very fault tolerant and very robust against transitory events such as clouds or failures of various sorts. We have a lot of conditions. You can start zaps. You can start when the target culminates. You can start at a particular date. We have constraints in terms of altitude, position of the moon, weather, and dawn and dusk that are customizable, and completion condition when the sequence set in the capture module or recorded in the capture module is complete. Repetitions or date of completion. When there is a problem, the object schedule will turn to aborted and eventually restart immediately or restart at the end of the schedule. So this was a big work during the last years, and it will continue to be very active. But we really need to have our tests up and running before we can continue. So it's a matter of being very stable and very, very resilient and robust. Scheduler module is all a question of knowing and trusting your observatory and how it behaves. There are two modules that we plan in the future. The observatory module, this is in construction. It controls a dome or a roll-off roof, parking state, shutter state, things like that, and also includes an access to a weather station to close the dome of the roll-off when something insecure happens. We also have the library module, which will store or display your frames, your exposures, and which we plan to connect to a series of plugins that allow small post-processing. The objective of Ekos is not to post-process your frames, it's to capture your objects. So it is the library module will allow to add some fits keywords to plate solve if it wasn't done before, and push to various backends. It will also be used to prepare for electronically assisted astronomy, mainly by pushing to another app, for instance. So for those who know already Ekos, what are the latest features? We've got mosaics, better mosaics, I think. The analyze module, multi-star guiding, polar alignment, the terrain on artificial reason, and StellarSolver. So before I leave it to the next presenter, I will just go through the scheduler mosaic tool, which was reworked recently. So I will switch between the two slides here. There are various use of the, maybe we want to make a pause if there are questions before we go to those latest features.
We don't have any questions yet, Eric, but
we do have a clarification there for those of you who aren't looking in the comments. This is a free software program, open source software program, and it is available to you. It runs on a Raspberry Pi, and what it's very popular as is people stick a Raspberry Pi up top their telescope and a few wires off to the cameras and maybe a little power up but that's it. That's what they've got. That's how it became very, very popular. So it's a good thing. Okay, who's next on the presentations here? Eric, you were going to do a
small talk about the scheduler mosaic tool. So very recently we changed a bit the way we saw mosaics to allow for how can I say, more stacking options. In the screen, you see that the mosaic, well, the usual mosaic we have is the one on the left, which are stitched mosaics, stitched frames to create a mosaic. Here, 2x3, which is already a lot of work, of course. But now we allow the tool to create mosaics that overlap a lot more. In that case, 66.6% of overlap, which allows you to have 9 frames stacked in the middle of the mosaic. in that situation, on the bottom right, this is 3x3 mosaic with 75% overlap, and the center frame has 9 passes, 9 frames. So the objective is to go just over the sigma rejection minimum of frames to bring in depth and dynamic. Still, the Mosaic tool is used to generate scheduler jobs. So you choose your target in the sky chart, you copy the coordinates in the scheduler, you choose the base capture sequence that you will use for all frames. You press a button and all the jobs are generated in the scheduler. And then all you have to do is to press play to start the mosaic.
Eric, I have a question before you move on.
Yes.
Why do you have such a high degree of overlap on the frames?
The idea that was introduced very recently was to do a single stack instead of stitching frames. Means that that 9x9 mosaic that is shown on the left-hand part of the screen here can be stacked once by union in PixInsight, for instance. Not necessarily in PixInsight, but you can stack all your frames at the same time and obtain a large dynamic at the center and a reduced dynamic when you go further from the center. So that's a different way of stitching mosaic frames.
So again, why would you want to have higher SNR or dynamic range in the center of an object rather than at the other 8 positions in this case?
It takes less time actually to create the mosaic, and that's just a different way to do it. In that case here, the mosaic on the left is larger, yeah, but you need to stack your frames for each of the portions of the mosaic. Also, on the right-hand side, if your object is in the middle and you want some background, some context for your object, you can achieve a relatively large SNR on the sides of the mosaic while maximizing the rejection, the process on the center frame.
But in neither case, you have the option to do it kind of the old-fashioned or traditional way, or the way where you have really the center of your field of view is really what you're interested in.
Did I answer your question properly?
Oh, sure. Please
Okay.
proceed.
Okay. So I will pass the microphone to Hai for his presentation.
Hi, you're muted.
Hi, can you see it?
There you go. You're good now.
Okay, great. Thanks, Eric. Hi, so this is a picture of me, astro imaging. I started, I wanted to give a little background. I just got into astrophotography 3 years ago, I think. And, bought a telescope on cloudy nights, got into it, learned a little bit about the field from the really excellent program at SJAA, San Jose Astronomy, whatever association, the local club. Learned how to do it, but I knew early on that the way I have been throughout my career, my technical career, has always been Unix or Linux, and I knew I wanted a Linux solution for my astro imaging, and so I found KStars and Ekos, and it's been wonderful. And that was 3 years ago, and about a year later, I started contributing. I was near retirement, and it was that time I knew I had to do some coding after I left my day job. And I found these folks and have been helping out with that since. And, pretty much Ekos was full featured when I started. I'm not saying that from day one, wonderful, like everything worked magically. This is a hard hobby. And it took a little while, several months, but I got it figured out. And I would say Ekos was pretty full featured back then. But if you know me, I just can't leave well enough alone. And I had some ideas that maybe how I might improve the program. And I'm going to take you through 4 things that I did. Of course, it's taking advantage of excellent work that was already there, but 4 things I did to help out. This picture, before I go into that, this picture shows me at the Golden State Star Party, GSSP, in 2019. It's a lie, right? Yes, I went to the GSSP in 2019, but the truth is 99% of my imaging is done in my backyard at home, not under beautiful skies. But that's a lot of people do that. And you see some wonderful astro imaging from home, from Silicon Valley with, light polluted skies or other metropolitan areas. And so some of the things I did, I try to help those kind of situations. So let's see, next slide. Analyze is one of them. Hold on, let me find out what I'm doing here. Analyze was this module that I created. I recognized, well, I was in the software engineer industry. I guess I started working in '83, and I was in grad school before that, a long time, and I debugged a lot of software. So I started doing astro imaging, and now I was debugging astro imaging, not the software, but the night sessions. Everybody's familiar with that. What went wrong, what went right. And I realized it was sort of tough to see. You'd wake up in the morning and you'd have a pile of pictures. But what really happened last night was the question. So I put this module together. It was a new module for Ekos called Analyze, where you sort of had an idea of what happened last night or what's happening right now. Or for that matter, you can use it to see what happened 2 days ago. So here you see the screenshot, and I'll show another one in the next slide. But what you can see, I know you can't see all the details on the screenshot, but the bottom line is, I think the most important one, or one of the 2 important ones, is the timeline, is the top rectangular window. And in the timeline, what you see are what happened by time. Time is the x-axis. The bottom row is your capture. So you could see that, I can't tell, there are like 16 red images that were captured, followed by, a similar number of green images and blue. Each one of those little squares is a capture. And if you click on one of those captures, well, I'll show you that in the next slide, I hope. Let's see, yeah, here. I clicked on one of those red captures, and out popped a FITS viewer to show you what's in the image that was captured. I'll go back to that previous slide. So that's what that bottom row is. You can sort of see, and it grows as the session is progressing. So you get to see how things are going. You can see the next line above that are the focusing sessions. And again, if you clicked on one, and in this particular slide, I've clicked on one, and on the bottom right, you might be able to see there's a detail on what happened during that focusing session. Looked like a decent session. There are other lines in that timeline. There's guiding, there's a meridian flip in the sort of the first third, and there's a mount timeline, that the mount is tracking, and so on. The next large rectangle below that is a rectangle having to do with plotting, and you can put various plots. You could see, you probably can't see, but below that are a bunch of features, and you can hit check boxes, and various plots get introduced to that. And in this particular example. The blue line is the HFRs, like how tight the stars are for the various captures. Each one of those little lines corresponds to one of the captures. The red line is how well your guiding is going, and then you actually see the guiding deviations there. And some more statistics below that. So that's what Analyze does. It gives you an idea. By the way, if you clicked on one of the captures, you can also see the guiding in the lower right. You can see a drift plot of all your guiding operations. So Analyze gives you an idea of what was going on. And you can, if things didn't go that well, you can sort of look at last night. We have logs for software development, but not so much for helping people sort of understand what happened. Like in Analyze, you can see this yellow line in this particular plot is the SNR, or the guider. It gives you a pretty good idea what the sky was like. You can see the sky's pretty rough around 10 o'clock over there on the right side of the graph, and then goes back. So if those red images weren't perfect, well, that was why. All right, that was the Analyze module. I want to say about the Analyze module related to software development in general for Ekos and KStars and INDI, is that we have an excellent forum where people post problems and we help them with it. But also I use it for when I have a new thing I've developed. I'll send a note out saying, hey, I've just developed this Analyze module. It's not in the release yet, but you can access it with our early releases. We have nightly beta releases. And you can, for that matter, you can compile the software. And people really help out. People test my work. People like, and everybody's, of course, not just mine, but people really are into these new features, and they really help the development. And they point out bugs, and they point out things I missed. And, I and the other developers were certainly not perfect. And it's really good to get feedback. So that's something I really appreciate, the strong community in Ekos and INDI and KStars for helping the developers as well as helping the users. Okay, so the next thing is multi-star guiding. Ekos supports PhD2, and when I started with Ekos, I used PhD2, and PhD2 is a wonderful program, no doubt. But everyone has trouble with guiding. I had trouble with guiding with PhD2. I currently have trouble, but most nice things work well. But there's no question that people are fiddling with guiding a lot. And I thought I had some ideas. And at the time, PhD2 didn't have a multi-star. They have introduced that. I had the idea of doing that as well. And I created an algorithm for multi-star guiding that is in the Ekos internal guider. So I should have mentioned, but Ekos allows you to guide with PhD2, but you can also use its internal guider, which is decent, and I've added some features to it. So multi-star guiding was one. You can see here what happens is there is something sort of a glorified guide star, which is in that square, but there are other stars that the guider keeps track of. We have excellent star detection that Rob will talk about. And so we detect stars all over the guide image. And when the guiding is getting set up, when it's finding the guide, what so-called finding the guide star, what it's really doing is identifying about 10 stars to keep track of. And more or less the deviation, the push that we give the mount has to do with the average, or actually the median deviation from all the guide stars. So we're hoping that gives you a better guiding pulse, that a little bit of the seeing influence is removed from that. And another really interesting aspect of this, something I didn't anticipate when I started coding it, but I realized during the process, was that not only does it help you with deviation, but it helps you find the guide star as well. You can see there's an interesting pattern of stars, these green circles, and it only exists really in one place in the image. So if you lost track of the guide star, if the guider did, for whatever reason, let's say a cloud came by, let's say guiding was suspended because of focusing and that jittered the telescope a little bit, it's actually pretty easy for the guider to find the guide star again, as long as the screen isn't wiped, the image isn't wiped out by clouds. But if enough of those stars are there, the thing can find the guide star. So it's both helping with the seeing as well as finding the guide stars. And you'll see later on when I talk about polar alignment, we also use it there. And here's polar alignment. So polar alignment and my next thing, terrain, both have to do with, I think, imaging from home, imaging where you have obstructions. And Jasem put together this excellent assisted semi-automated polar alignment system a few years back. And basically what it does is you hit start, it captures 3 images, an image, it slews RA, captures another image, slews RA, and from that figures out what the axis is, what the RA axis is of your mount. But if there's a tree right in the way, I mean, that system needed to see the North Pole if you're in the Northern Hemisphere, or the Southern Pole in the Southern Hemisphere. What if there's some obstruction there? What if your house is in the North, or whatever? And so, well, it turned out that with a fellow related to KStars pointed out that you don't need to see the North, to see your polar star in order to figure out what the mount's axis is. Now, thank goodness for the web, and spherical geometry wasn't something on the tip of my tongue, but with a little Googling, I realized how to put this, I figured out, and with help of others, how to get this to 3 images anywhere where you're slowing the RA motor, and you can find what the axis of your mount is. So the advance here is that you can polar align without, not drift align, but this is pretty automated. The system will take the 3 images and figure out instantly what the offsets are, and then gives you sort of a target to look at your screen and view a star and move that star by adjusting your altitude and azimuth knobs to a certain position and put your polar aligned. And in fact, I haven't done this, but if mounts come out with motors for altitude and azimuth, it could do it fully automatically. So there's that. And another feature that bugged me, I shouldn't say bugged me, but anyway, KStars I thought could be improved. I really like the Stellarium landscape overviews, and we didn't have that. And when you're imaging, it's good to know when things are going to come into your, behind some obstruction locally. And so I added a feature very similar to the Stellarium landscape, where you can add your own view into the KStars sky map. This is done by taking a picture with your phone. You need a spherical picture. Google, for instance, Google's camera phone does that. And there are other ways to do that. And you can superimpose a picture of your local view onto the sky map. What I've done, well, Jasem already had a way of entering sort of coordinates into it so that the sky map could be colored but based on what is obstructed. And if you have this background now on the sky map, then it's even easier to add these coordinates, because you can just click. As you can see in this diagram, this is my house, and I've clicked around my obstructions and created a definition of what my real horizon is. Not the horizon at the horizon, but what I can actually take pictures of. This currently isn't used by the scheduler, but that's the next thing, is to get that into the scheduler. So that'll probably be in the next release or 2. Okay, those are 4 features that I've added recently in the last year and a half or so. And now I'm going to hand it on to Rob for his latest work. So Rob, take it away.
Rob, before you get started, just a couple of quick questions. I think it was in Eric's presentation. Do you also control rotators?
We do also control rotators.
Okay.
Really quickly. Yes, that was added in the last release, I believe. Jasem might pipe up on that, but that was added in the last release.
And a question came up. Let me just read the question. I see that some of you are over on YouTube, so if you want to answer the questions on YouTube, just go right ahead. does it mean you are guiding multiple stars at the same time? If so, does it also help with field rotation?
Well, let me say this about that. I would like to think so, but honestly, it's really hard to measure this. And that's one of the things that's frustrated me. Like I put a new guide algorithm out there, but I spent 30 years, or 40 years, I guess, in industry doing, engineering research where I, had large data sets and would measure improvements in the algorithms I developed. And it's a little harder to do it here in this field because you don't really have access. Did I improve guiding? I think so, but I can't give you a scientific answer for that. But I believe the answer is yes.
Another question without a question mark. Please, if you're on YouTube, put in a question mark if you have a question so we know. Can you use dithering functionality if you are not guiding?
That one's for Jasem, I think, or someone else. Jasem, you're muted, by the way.
Yep. So the answer to that is yes. Actually, we do support non-guide dithering natively in Ekos as well. So yes, the answer is yes.
Okay. One more quick question I have myself. How many users of your system do you have out there? Do you have an idea? I mean, you must.
So actually, due to the open source nature of Ekos and KStars, we really don't know. One metric could be the contribution to the forum and how many users there, and we have lots of users. But actually, since this is an open source software and there are many ways of getting it, of downloading it, of distributing it, we don't really have a tab of how many users that are actively using it.
So now that I start to ask questions, a bunch are popping up. Let me read this one. What's the best way to get updates as soon as they are available? Is there an automated process?
So unfortunately, there isn't a built-in updater in KStars like a patcher. So whenever there is a new release, you have to download and install that. And but you don't have to worry about that. And it's not really a big issue now with very fast internet bandwidths available to most people. So all the settings are kept in place. The settings are all reserved, and you just update the software through that.
I think those are all the questions. So if you want to go ahead, Rob.
All right, just 1 second. You see that okay?
Yes.
Okay, thank you. So just a quick introduction. I'm a little different than some of the other presenters that you've been seeing this evening. I'm a physics teacher. I'm not a professional IT person. I'm not a professional programmer or anything like that. I'm an amateur astronomer. I've been doing astrophotography since I was about 18 years old. So that's about 20-something years ago. And I got started, with a regular old film camera and gradually moved up from there. For a number of years, I was using astrophotography software on my Mac, and I go out in the field to do my imaging. I don't usually do it at home. Although I've been doing it more recently due to the pandemic and issues like that. I like to get out under dark skies and take my stuff out there as far as I can get away from the city lights. You can see here is a picture of me controlling my scope. This was actually earlier on. This was a telescope that I built and connected to my computer here. This is soon after I built that. And it's actually before I got started with KStars and INDI. So you can see I'm kind of struggling here with the connections between my equipment. It's sitting on top of the box. I have a much better setup now that I started using KStars and INDI and can strap a Raspberry Pi to the side of my scope, set up my computer in a nice little thing, a nice distance away from it. And so that's really helped. It's made a huge difference in my astrophotography. So when I got started with KStars and INDI, I basically just had gotten an email saying that a program that I was using had added INDI support. And I said, well, what's INDI? And I was at the same time, just as a coincidence, I had received an email from the company of the software I was using to do my astrophotography, and they were saying they were discontinuing the Mac software that I was using. And a lot of the other options out there were really expensive. So at the same time, I was getting these two different emails, one saying, oh, we're adding INDI support, and another one saying, oh, the software you're using doesn't work anymore. And it was just a magical event. And I found this rabbit hole that I started going down into, which was KStars and INDI. And it really revolutionized what I've been doing with my astrophotography. It really took it to the next level. It gave me the ability to control my stuff remotely over Wi-Fi or Ethernet instead of having all these cables connected, as you can see there in that picture. It allowed me to get much better images because I can do plate solving and all these wonderful things for free, which is really cool. I started out just using it, and I slowly got more and more involved. I started making recommendations about changes that could be made. And then I started kind of tinkering and making some changes myself and submitting those. And I actually started improving with my coding skills as I did this and thought that was really neat. And so I just kept getting more and more involved. And before you knew it, I was writing Raspberry Pi scripts to set up your Raspberry Pi automatically. So you buy a Raspberry Pi, run my script, it's all set up, ready to go. And there's a number of other people that have done that as well. But I really got a nice benefit of doing it myself. I thought that was really cool. And then I figured out a way that I could install it on my Mac and started getting more involved with that. And I eventually ended up with a group of other people kind of porting the program to Mac. And then I've had little projects along the way, like I've changed this, I've changed that, added my little feature here or there as I saw something cool that could be added, and improving things that I saw that needed fixing. So you really don't have to start by doing anything really big. If you try some little things first, you can kind of get started, and then you find out you really like it, and then you get more involved. So the main thing that I'm going to talk about this evening is a feature that I created last year, which was a huge project. I did it during the pandemic. It's called the StellarSolver. So if you don't know, about 10 years ago, astrometry.net was released, which is a really powerful plate solving program that works incredibly well on a number of different systems. Astrometry.net, though, is designed for Linux. And if you want to run it on a Windows computer, you've got to use an emulation layer of some sort, such as Cygwin or Windows Subsystem for Linux. If you want to run it on a Mac computer, you have to install a whole bunch of Linux dependencies. And they do make a number of different systems where you can do that, such as Homebrew and MacPorts and Fink and other things like that. There's a variety of ways you can do that. But all these different people have different systems. Like some people are using one system or another system. And the configuration of all that can be quite complex. I know that when I got started using astrometry.net, it really changed my imaging and made it much more powerful. And I thought it was awesome that I was able to do it on my Mac with KStars, but it was hard to get it set up. And so one of the projects that I was taking on early on was trying to make astrometry.net easier to use. And over the years, it got a little better and a little better. I started adding little interfaces to make it easier to enter the parameters and things like that. And then I really got frustrated because Python configurations that people had that were different on their different systems were really causing headaches for me. And then I found a note on Astrometry's website that you could use SEP if you didn't have Python. And I got to thinking, maybe we could take the star extracting power of SEP that we currently had in KStars. What if we combine that with the power of astrometry.net? So we did the star extraction with SEP and sent that to astrometry.net and plate solved. And then we could totally avoid the problem. And it worked. It actually worked quite well. In fact, it worked so well that people were saying that it was solving faster than it did before when it used the built-in solver. And I was like, oh, what? I was kind of surprised, actually, that that was true. And so I found that it might be good to keep working on this. And this was about the time that the pandemic was starting. So I had a little bit more time on my hands because I was stuck at home and we couldn't travel anywhere. You know, all we could do is do work and sit at home. So I really started messing with this and seeing if I could make it even better. And eventually I made it into its own library that would be internal to the program. So it'd be like an internal program instead of a separate one that you had to install and configure on your system. And I eventually expanded to not just make this work for a Mac, but also to make it work for Windows as well. So this is a full internal plate solving library built upon astrometry.net that can use its own internal solver or other solving methods like ASTAP and the online astrometry.net from nova.astrometry.net, as well as a couple of other methods. But also, it natively solves internally to the program, so you don't have to install these external dependencies on your computer. And another problem that I was finding was there were a lot of external configuration where somebody had some information entered in this external file that might have been incorrect, and they couldn't find it. They couldn't find the file, and it was very difficult. So I found that I could like send those settings from KStars to that program, and it avoided the whole issue. Or if it's using the internal solver, it doesn't have to send anything out. And I could get those settings internal to KStars and avoid all those problems. So that really made a big difference too. Also, not saving those external files and not saving files to the hard drive, like image files and stuff like that, could really save the memory on the Raspberry Pi in particular, because Raspberry Pi, of course, runs on a flash memory card, which can get worn out if you have to keep saving files all the time. So if we can keep everything internal to the program, we can avoid any writing to disk. And so we avoid that problem. And, you know, the pandemic kept going on, so I kept adding to this program. And I came up with ways of speeding up the solving by using parallel processing, using different computer cores. And I eventually got this to the point where it could blind solve something that used to take several minutes in several seconds. And I was like, this is awesome. And so I kept playing with it, kept adding it, and kept improving it. And now it's been integrated, it's been integrated into KStars. And so I was fully a part of it. See, originally I took it into a separate program to play with it, and then I brought it back in last October into KStars. It was slightly difficult to get it to go back in. You know, I took the code out of KStars, worked on it, and then tried to put it back in. It didn't fit anymore because there were changes that had been made. So we had a little bit of pain back in October trying to get it all working again. But it seems to be working quite well now. And I think it's pretty good. I wouldn't say it's totally finished. It probably needs some more work. We'll keep working on it probably this summer. But it's a huge improvement, I hope. So I'd like to talk also in my time about what makes KStars and INDI a little bit different than the other things out there. So this is software that's developed by people that do astrophotography for other people doing astrophotography. So we're not a big company trying to, you know, develop a product. We're a community trying to develop better stuff for us. So it's like, you guys say you want this, let's add it, you know, let's improve it. So we're trying to make an open source program that you can get for free, that everybody can contribute to and say, I want it to be this, I want to add that, this is really cool, let's see if we can add that. And that's actually really powerful, I find. And it's really improved my imaging, and I hope it does everybody else's too. I really like the fact that it supports all these different platforms. You know, we now have it supporting Linux, Windows, and Mac, and it works pretty well on all those systems. And I think that's really powerful. I really like the flexibility, like you can run everything on one computer, or you can have a Raspberry Pi remotely controlled by a Wi-Fi or over Ethernet. And there's so many different options, and that's what I think is really cool about it. So one thing that makes it even better, I think, is the online community. The fact that you can go onto this forum and talk about different ideas, talk about how you can improve the software, debate new possibilities that the software could have, ask for help, you know, troubleshoot your system, and, you know, share your knowledge with others. So I think that's the thing that really makes it powerful. So how can you get involved? How can you get KStars? How can you get INDI on your system? Well, if you want to download and install KStars, you go to the KDE website that's listed here. If you're interested in INDI, you can download that here. You can go ahead and start using the software. It is free. You can just start playing around with it and seeing if you can get it to work on your system. If you find any issues or have any trouble or have any bugs to report, the forum is an excellent place to do that. And you can get tons of help in there. You can discuss things, get assistance. And we really appreciate if people test our new versions of the software and provide us with feedback so that we can make improvements. Now, if you get really interested and really excited about what's going on like I did, you might be asking yourself, okay, how can I help? How can I get more involved? Maybe you don't have tons of coding experience. I know I didn't when I started. I mean, I teach computer science. I do teach a small course in that, but I didn't have any experience with C++, and there's a lot of C++ in here, and I learned as I went along. But you don't have to do that. You know, you can just help new users. That's what I do, just helping other people in the forums, answering questions, seeing if you can troubleshoot any issues they're having. You can discuss and debate new ideas, talk about new possibilities the software could have, give some suggestions to the developers. One thing we really, really, really need, and it requires no technical expertise, we really need people to write instructions and websites and manuals, because we're not very good at that and we really need help. So it would really help if you could do that. Another thing that's really helpful is creating videos. There are a number of people that have done this online, like YouTube videos explaining how to use different features in KStars or different features with INDI. It really is helpful. And if you do have any coding experience, we could definitely use help. We do have probably dozens of people helping very actively. It's one of the most active GitHub pages I've seen, but we could use more. We definitely could use more help. And if you're interested in getting involved, you can contact Jasem here. He can help you out. So at this point, I think we're opening up to any more questions.
Great presentation, guys. I mean, I use ACP now, and I'm just pondering with a new system setup. Maybe I should think about this. And I bet a lot of other people online or that view this will have the same reaction. I do have a couple of questions. Can you automatically upload your captures to the internet or to a remote desktop site? I mean, the Raspberry Pi only has so much capacity.
You know, that's sort of a Linux. I can give you a Linux answer for that, which is you can certainly have scripts and programs that sync folders across computers, and that's the current solution. So it's not built in to KStars Ekos yet, although Eric was talking about a future for that. But right now, it's easy to do with Linux. You know, yes, you need the Linux foo to be able to do that, but that's doable.
But for an ordinary Windows user like myself, it's...
Well, you can sync remote directories. There's a Linux program that does that, and you can set that up. Or, you know, you do what I do, which is in the morning, you grab your stick off your Raspberry Pi and you plug your stick on your Windows machine.
You can also, with the most remote desktop software, download whatever was out there.
Sure. So I have another more basic question. I mean, you're all astrophotographers. Are there any images you want to take a few minutes to share?
Oh, I could do that. So the one behind me was taken with KStars.
Well, take it. I mean, we all like to see pretty pictures. If you guys have something you'd like to demonstrate with the results of the program, you know, go for it. Share your screen.
Yeah. Just give me a moment.
I see in the meantime that Eric is taking responsibility of answering all the questions on YouTube. Thank you.
Can I ask a few questions? Can I ask a question? Can you hear me?
Yeah, we can hear you.
Yeah, go for it, Thierry.
Oh, okay, yeah. If there is an ASCOM driver available, but no INDI driver, are there any solutions?
Jasem, you can take.
Negative. So we only support INDI. There is no support for ASCOM. So, and this happened to a few users where there is only an ASCOM driver but no INDI drivers. So you can come to the INDI website and ask us. And more often than not, you will get a driver up and running in no time.
Okay. With a Raspberry Pi, is it best to run the remote devices off their like an individual Raspberry Pi, like all the peripherals on the remote devices, or is it best to run it off just one device?
You mean like more than one Raspberry Pi, or?
Yeah. Like if you had say you're looking after your dome as a remote device, would you run that from a Raspberry Pi, and then have your main Ekos system connecting to it, like basically offloading that processing to that device?
Right. I mean, you can actually run Ekos within the Raspberry Pi as well. I wouldn't highly recommend that. It depends on your setup. So for example, in my setup where I have like a gigabit network at home and my observatory is just, it's just upstairs, it's just a few meters away from here. I use remote connection through Ekos. So Ekos is on my BC and I remote to the Raspberry Pi up, and the Raspberry Pi is connected to my cameras, it's connected to my auxiliary devices, it's connected to my roll-off roof. So it's connected to everything. A single device connected to everything.
Okay, thank you.
Along a similar vein, so right now I use Windows machines as my data acquisition machines. And it looks like that you can't like control your devices from a Windows computer directly in Ekos, that you need to have like a Linux system in between the two of them or something. Is that how that works?
Correct. You need to have INDI. So INDI is natively supported under either Mac OS and Linux. So if you have a Mac OS system, you don't really need to. Raspberry Pi is not required. But if you have a Windows machine, then you must have a Raspberry Pi or a Linux machine somewhere. You cannot use it directly with Windows.
Okay. So if the Raspberry Pi is what the devices are all connected to, can you not use Ekos with Paramounts in that case, because you have to control them with the SkyX?
Well, there is support for Paramounts through the SkyX because that's actually being installed on the Raspberry Pi. There is actually support. Yeah, so they can be installed, and we have users who actually do that. They install the SkyX on there, and they use the INDI Paramount driver just fine with that setup.
Okay. So on the Raspberry Pi, you install what do you install on the Raspberry Pi to actually talk to the devices? Is it just the INDI drivers, or is there like a master kind of like communication software that brings all those devices together?
All right, that is an excellent question. So because this is a Linux system, there is like literally a million ways for you to do it.
Okay, yeah.
But saying that, there are prepared images that you can just take and download. So for example, you can use StellarMate, you can use AstroPerry, you can use Robert actually wrote a script that you can just fire up and it will download everything and build it for you. Okay. So there is a lot of ways for you to get the software, because it's INDI, but it also needs other software components for everything to be running smoothly.
Okay, hold on for a minute here, guys. We asked the guys to show us some pictures, and then we proceeded to ask them questions, which talked over their pictures. So let's go to Hi. How's your Pleiades doing there? Hi.
All right. Well, Rob and I have been trading off showing pictures while people have been talking, but you're saying you weren't on the screen? Anyway, this is just a series of pictures that I took. I'll just do it really quickly. This is all, of course, Ekos. And for me, different people use Ekos differently. I use it all on the one Raspberry Pi, right? So all the programs are running on the Pi. I use my laptop just with some remote viewing software, or remote desktop software, but it's all the Raspberry Pi. I'm going to stop sharing and let Rob give it to you.
Robert, did you have some you were sharing?
Yeah, I had a couple I was sharing. So what he was just saying was that he does everything on the Pi. What I do is I use my Mac to control the session, and I use the Pi as the thing that's connected to all the devices. So I have a totally different method. Just a second, I'll find those images again.
You mean to tell me you guys invented all this software and everybody uses it however they darn well please?
That's correct.
Those imagers.
Awesome. That's what makes it awesome. Here, I'll share that. Can you see this?
Yeah, you're presenting now. There's a M42.
Yes. And I like this because it's probably one of the better images that I've gotten of that, because it shows clearly the Running Man as well. And I like that one. Took that in 2019 because I was going to get another one up. Hold on.
You know, while you're just talking about Pi versus laptop, you know, the advantage, the Pi is slow, right? I mean, it's not slow. It's fast enough to do all this stuff, but it isn't as fast as your modern laptop. And you'll notice that. But you can get everything to work on the Raspberry Pi. That's the advantage and disadvantage of that. When you go to a laptop, then you got to keep that laptop running all night. And so it's quicker, no doubt. But the downside is you have another computer that you need, to make sure it's. So those are sort of the trade-offs you have.
So this one's Pickering's Triangle in Cygnus. And this one's interesting because I think I did this one at home, whereas a lot of the other stuff I didn't do at home, because this one's entirely narrowband. It's just H alpha no 3. So I was able to do that for my driveway.
Okay, thank you for sharing. Are there any more pictures we're going to see, or should we proceed with the rest of the show?
One more, if you
Okay.
don't mind.
Okay.
I particularly like. Hold on a second. This one. I'll share that real quick. Hold on a second. This one's kind of interesting. I did this at the end of a star party. I was just getting done with my imaging and it was kind of cloudy, and I was like, maybe I'll do one more thing. But the fact that it was coming through the clouds acted as an interesting filter, which made this star blow up all blue like that, which made a nice contrast with the reds and the oranges of the horse head and the flame. It was really cool, I thought.
Okay. Let's see. We've got a few more. Eric, you've been monitoring. We've got some questions we've got to get asked.
Yeah, actually, Eric has been answering most of the questions in more or less real time.
Okay.
Nice.
So can you use two cameras? Not quite sure what that question is. Does
I
that
answered
mean
that one on the chat, but the question was, like let's say you had two ZWO cameras, one for guiding and one for imaging, would that work? And people do that all the time.
Oh, yeah.
sure as opposed to two for capture?
Well, as opposed to worrying, that the software would be confused and not know because it's the same driver, but it doesn't. It isn't a problem.
Yeah, and I think there's another question. Can you run two different rigs at the same time? Meaning, you put two tubes or two cameras on the same mount, and you want them to start their exposures at the same time and close them at the same time. Can you do that?
So I can give you a solution to that. You can't do it on the same computer, but because the Raspberry Pi is a small computer that can be mounted to the scope, you can have a Raspberry Pi on each scope, controlling the whole session for that scope. and then you can connect remotely from your laptop using a remote desktop program.
Yeah, but the issue is more complicated than that, because I'm thinking of doing just that. For example, if you have a long focal length and then a wider field focal length, you might guide on one and not on the other.
Oh, yeah.
And when you're focusing in between, of course, you're moving the thing around, so you can't be capturing on the wide field when you're doing other things which are moving them out. So you really have to have some coordination in order to do it.
That's right.
I'm sorry?
You're right that you need coordination, and you don't want to be, like you say, capturing while you're moving, and so on and so forth. And that's a commonly requested feature on the forum that isn't implemented. So that's, maybe there will happen in the future, but not right now.
Yeah, that's why I was asking it, because I know it's popular for a lot of people.
It would be a very nice feature to have, especially on those mounts that can easily carry, let's say, I mean, you probably wouldn't want to have two of the same scope. Normally this question comes up when you want to have a wide field and a narrow field on the same mount, and do images where you put more resolution into wider field images. So that would be a feature that I think would get a lot of attention from user groups or from me.
Or another way of thinking, Eric, is you put your one-shot color on one tube and a matching tube, matching size sensor, a monochrome on the other, and catch your LRGB all at the same time.
I've tried that in the past with a long focal length instrument with a wide color camera. So as my long focal instrument rotated, it encompassed the rotation of the wide field color camera. But I still had issues that when it wanted to do a focus bump, it would go over, focus, and come back, whereas the other guy just kept clicking away. So I had to manually go through, cull the images that were no good. It worked, but it was not the best. You needed a system where you hand it off. I'm finished. Are you finished? Yes. Let's do the next slew.
Yeah. Anyway, you guys work on that for the next time you come back, eh?
Well, I've thought about this issue for a long time, and I actually have a wide field setup that I want to put on the other side of the L mount, but I don't have a real good software solution for that. So let me ask the same question another way. Could perhaps your software work with some more traditional capture software and just take instructions so it knows when to make those shots when the other software is not moving them out or doing focus or doing something else, which would mess up your wide field setup? Will it talk to those other pieces of software? Not yet.
Negative. I'd like to say that we actually officially have this feature for supporting multiple cameras, not just two, in the in our issue tracker, because this has been requested. This has been a requested feature for a number of years, but to actually implement it and to take care of all the complexities involved in orchestrating multiple cameras, it would take KStars some re-engineering to actually support this feature. And if we're going to support two cameras, we might as well support three or more. And so this is actually officially part in our issue tracker right now. And I can't make any promises as when it will be available, because it is such complex issues. But I agree, once we have it there and once it's mature enough, it's going to be like a deal breaker for a lot of people. This would be a major feature.
You mean something like controlling like a Dragonfly setup?
That sounds neat.
Okay.
You mean the controller, a Dragonfly?
Mm-hmm.
No, the setup with 6 cameras, actually.
More.
Okay.
Okay,
Yeah, so it's
everybody?
going to be N cameras.
That could be nice.
That's the plan.
Future development.
All right. Have we cleared out the questions queue?
I think we have. In fact, we've gone beyond the question queue.
And we've given information as to how to get the software, right? We've told everybody how to do that, how to get help. Does anybody know what time it is in Switzerland, for instance? And we got somebody from France, we got somebody from Switzerland staying up maybe they got up early. Maybe they're staying up late.
4:55 a.m.
4:55 a.m. Yeah.
That's what they want.
Anyway, and we got somebody from San Jose. Where are you? Delaware, Robert?
Yes.
Where are you? Yeah. Okay. So we got people from all over. The beauty of the internet. Curtis is coming next week to tell us how to power our rigs when we're off on remote. And I'm certainly waiting to hear about that because I've been working on a project. I had everything worked out fine until I bought a new camera. And I can't get things to work with the power that the cooler requires. Had everything working on the old Canon 6D, but put the cooler on it, and it's a whole nother ball game for me. So anyway, where are we? Let's see. Any new questions come in?
I think we're all
Don't
set.
think so. Okay. Thanks everybody for being here. We'll be next week with Curtis. Get your gorgeous galaxies in, your gorgeous, gorgeous galaxies, so we can put them all together in our slideshow. And Molly, you're in charge.
All righty, I'll take us out. Good night, all. Thanks for coming.
Good night, everybody.